So, we will first start with some questions on quality. Okay. What is your understanding on quality, and from there we will drive how that is likely to be different from the actual definition of quality. Okay. But before that, we also will explain. Okay. This is just to give you a what do you call like an bird's eye perspective. Okay. So, all these come under a big umbrella, all these type of studies come under a big umbrella called design under uncertainties or decision under uncertainties. Okay. You can take any example. Okay. You can take a doctor, for instance, a surgeon. Okay. So, we work with a spine surgeon, okay, we work with a gastroenterologist. The success of such surgeons, if you look at it, is how quickly they can make decisions in the face of uncertainties. This is all it is. So, this holds good for anything. You take a cricket player, for instance. Okay. If everything is nice, okay, what is the big deal in playing? Okay. Why was Dhoni celebrated that much? Because he was a match winner. Okay. When everything is going down, he is a single person who will stand there and play the game and win the game for the country. Okay. So, that is called uncertainty. If everything was given to you, very nice pitch, okay, a bowler who will bowl to your bat, there is no big deal. Okay. You will play against a tough team, okay, who will bowl at a very high speed, they can spin the ball, okay, and there will be dew that will be set on your thing, and the crowd might be against you. Under all those conditions, how do you play against all those conditions and still win the game? Okay. So, that is what these are all the uncertainties that I am talking about. So, in a similar fashion, for a car, you cannot design a car that you will say like, okay, this car was designed for Chennai. So, it will only work under like heavy sunny conditions. You cannot drive it in snowy weather. You can always say there is a car that is a 4-wheel drive, it is better suited for snowy conditions. Okay. But you cannot say that this car will not perform under snowy condition. Okay. So, a car has to perform under uncertain conditions as well. Okay. So, all these things come under the big umbrella called design under uncertainties. So, the uncertainties happens in multiple stuff. For instance, classically, where does uncertainties happen in a manufacturing senses? In the material property. For instance, in the strength of materials, one of the important material property that you discuss is the Young's modulus. The Young's modulus is usually given by a single word. So, basically, if you take the Young's modulus, for instance, predominantly we have used it in a deterministic sense. So, there will be a single value that is given. But if you realistically, if you look at it, if you take a particular specimen of that particular material and run a stress strain curve to identify the Young's modulus, okay, between two different specimens, the values are likely to vary. So, there is an uncertainty in that. Where does this uncertainty come from? It might come from the material itself, the way in which the material was made. It could come from the way in which the technician actually tightened that particular or fastened that particular specimen. Okay. The way in which the specimen was machined. Okay. There are several things. At what point in a day was this specimen tested and this specimen was tested, that could also have an influence. Okay. So, basically there is variability in the material property, then there can be variability in loads, then there can be variability in geometry which comes from the manufacturing aspect of it. So, all these things will influence the performance. Okay. So, it is very important to consider design under randomness. You cannot say that the design is deterministic. You cannot say the load is this much and it will work. No, not necessarily. The load can be larger than this. In classical design, how do you think we account for this randomness? Because we have built airplanes and ships and cars and bridges, okay, all knowing that there will be uncertainties in the loads, uncertainties in the material properties. It is just that with technology we might have been able to control these uncertainties a little better, but still uncertainties have existed forever. How do you think in classical design we treated these randomness or uncertainties? You have used factor of safety. When you do design, finally you use something called a factor of safety. Usually what you do with the factor of safety is you either use a load factor of safety or you use a material load factor of safety, right. The load factor of safety says if you are going to apply 1 unit, you put a 20% on it, 20% factor of safety. So, you say instead of 1 unit, I am going to apply 1.2 units. So, in reality, you will be only applying 1 unit, but you are over designing here by saying that I am going to apply 1.2 units. Similarly, if you are going to account the factor of safety in your material property, what you will do is you will make the material property weaker. Okay, if it's 1 unit is what the material property is, you will make it 0.8. Okay, so you will design it for a weaker material so that it can the actual design is stronger. Okay, so this is how we have done, but these techniques let you take care of those uncertainties in a slightly better way so that you don't have to over design. So that is, and it gives you more insight into the failure mechanism. That's the idea of this whole thing. Okay, so there are different ways in which people look at uncertainties, and that itself is a research area, because when you say uncertainties, this is not only in structural design or mechanical design or engineering design in general. Okay, uncertainties exist in everything in that, as I told you, like for instance in finance. Okay, finance engineering or any kind of an investment banking systems and all that, uncertainties is the most important stuff. Okay, weather prediction, stock markets, all these are heavily influenced by the uncertainties. Okay, today one of the major things in the climate change stuff is predictions. Why it is very difficult for us to predict whether there is going to be rain this year or not. You can always predict whether there is rain tomorrow or not, that with much larger confidence compared to 8 months before. Okay, so the problem is you need to understand the physics behind that, so that you can will you be able to forecast. So similarly, if you want to invest, you have some money and then you want to invest in shares. Okay, the question that you have is, what is the probability that this particular share is going to be greater than that value? If you know that a priori, you can happily invest, but if you know that that particular share is going to go down 8 months from now, that you will not know. But let us say that you have the ability to predict that, then you will not invest in that. Okay, so now there are mathematical models, statistical models that kind of let you, not always, see that is the strength of probability, right? It's only a probability that this is going to happen. Okay, in a statistical sense, it's going to happen. Okay, it is not a guarantee that it will happen. Okay, so the forecasting models and prediction models, this is what they do, and this is what this majority of the AI is all about. Okay, with all this data that you have, can you predict, can you forecast? So that's what they call it as prescriptive. Okay, predictive analytics. And then the moment you predict, can you prescribe something to that? Okay, if there is a problem, what does a doctor? The doctor prescribes medicines to you. So if you can predict using analytics, can you also prescribe the solution using analytics? So that is what it is coming, right? So there are different ways of looking at it, but one widely accepted way of looking at uncertainties is there are two types of uncertainties. One is the elateric uncertainty and the other one is the epistemic uncertainty. Don't worry too much about the words, we will look at the concepts as such. Okay, the elateric uncertainty means it's the inherent uncertainty. Okay, the uncertainty that we spoke about. Not all of you are of the same height in this classroom, not all of you weigh the same in this classroom, not all of you are going to perform the same in this classroom. Okay, are the instructor different for each one of you? The instructor is the same. I am the instructor. Okay, I am sitting here, I am being videographed, everything is the same. Okay, the environmental conditions is the same, but you think that all of you are going to get an A grade? Even if all of you get an A grade, let us say, okay, not all of you are going to get 80, someone might get 82, someone might have got 78. Okay, still all might fall into an A grade. Okay, but points wise you might be different. Okay, so there is an inherent variability. Okay, I might strive to minimize that variability, you might strive to maximize that variability, that is a different stuff. Okay, but there is an inherent variability. The wind speeds, there is an inherent variability. Performance of car engine, inherent variability is there. Okay, Whereas the epistemic uncertainty comes from the lack of information or data. When I said a digital twin, what I said is there is a physical car and you have a car on the computer. Okay, the car on the computer is a numerical representation. You can visually see a car, but when you crash, what happens is it's going to solve partial differential equations at the back. A finite element analysis is what? Visually you can see stresses and forces and all that. That is only for us, for our naked eyes to appreciate that. But at the back end, what the computer does is it's actually solving partial differential equations, right? So this car that you see on the computer is only an approximation. It's only as good as your mathematical representation. It's only as good as your numerical representation. So that again comes from my limitations on how much I understand the car's mechanism. Okay, it's only a approximation. For instance, today people are trying to model blood, they are trying to model skin, okay, both from a decision perspective and both from a product perspective. Okay, people are trying to come up with materials that are equivalent to skin. Okay, they are trying to do that. Okay, so for instance, if you were to do these kind of stuff, if I have to develop a model of a skin, I need to understand the skin or the muscle mechanics, okay, or the concepts of how these work or how these exist. So I would start with a simple model and then I will build up the complexity in the model, right? So that's where it comes, that due to lack of information, okay, and it gets refined. As and when I get a little bit of an understanding on the skin part, then I will try to bring the non-linearities into it and then the model gets refined. So that's what is epistemic uncertainty. What we will predominantly discuss in this course is the aleatoric uncertainty. Why predominantly? We will discuss only aleatoric uncertainty. We will not be talking about epistemic uncertainty. We will only talk about aleatoric uncertainty, which is the randomness or variability. These are the words that are usually used. Uncertainty is a fashionable term. Okay. So for you, the word that you might have already been used to is called the randomness or variability. That is what we are going to look at. Okay. Now the first learning of this course could be this particular stuff. What is quality? Okay. This word is not new to you. We've been using this word, quite often we use the word quality. Okay. We have now started using it for anything, buying a pen, buying a cell phone, buying a jewelry, buying a computer, buying a bicycle, buying a car. Anywhere and everywhere you can, people use the word quality, right? So what do you think quality is? I don't want a textbook definition where you say a quality is a property by virtue of it. No, I don't want that. Okay, what is your understanding of quality in your own words? You need to interact. We are on the video. You need to interact. Eventually, I will tell the answer, but you need to interact. I cannot run the course for the video. Yeah. There is no unique answer, so you can answer. They are built to meet the desired specifications. Good. Sorry? Durability, lifetime. You are giving me hints to develop or what? Can you frame sentences? Imagine I teach course like this.
It must deliver the same quality as like.
Oh, no, you cannot use the word while you are defining the word. I am asking who is Kuldeep. Okay, so you are saying Kuldeep is someone who looks like Kuldeep, So that is what you are telling. So that is not allowed. You should tell me features of Kuldeep. Then I will know who Kuldeep is. Like that. What is quality? You cannot use the word quality in trying to define quality. That's all it is. Yeah.
So basically, whether will be having some proper benchmarks and metrics, so if the product is meeting those things, we say that quality.
Okay, so there are some benchmarks and metrics, and if your product meets that specifications, then it is called a quality product. Is that right? Okay. Anything else? Okay. So whatever you guys told is right, but it covers only the partially. It covers only partially. Okay. The deal is, majority of what you are talking about is until you go and buy. When I am buying it, you are asking, oh, did it meet the specifications? Yes, it did meet the specification. So you say it's a quality product, but does it stop there? As a buyer, my experience starts there. It does not stop, it starts there. Okay, how do I care until then whether it is quality or not? I am worried after I pay. This is important, right? If you give it to for free, I don't care. It works, it does not work, I don't have the right to complain. But the moment I pay, there is some expectations from my side. The moment I spend some time teaching you, there is an expectation from me. Okay, the moment I pay and then I get something, there is an expectation for me. But can I have a wild expectation? No. The product comes with a specification and an expectation also. For instance, the X kilometer per liter is what the expectation is. The example that we gave, X kilometer per liter is what your expectation is. There is a higher priced car. Okay. The reason that it is higher priced is there is a luxury, it is in the luxury segment. Okay. So, I should necessarily feel luxurious when I sit in that. I should necessarily feel comfortable when I sit in the other car that was more expensive than that, because that is what was promised to me. Okay. They said there was another car which was even more expensive. The expensiveness comes because it is really safe. Okay. It had like some 6 airbags. Okay. It had other sensors and all that, which will allow you to, or which kinds of guides you out of a accident, okay, before it happens. Okay. And it has to do that. Okay. So, there is an expectation. The moment I pay that higher price, I expect it to perform. So, the important part, or not necessarily the important part, but one of the part that was missed in your answers is how it performed after I bought it. Until then, you are only talking about what is there on the showroom. What I will be interested more is after I bought it, how is it going to perform to me? See, I can always have a very high expectation, but that cannot be met. There is I tell you as a seller, I tell you this is your product and this is what you can expect and this is what I promise. Okay, I say this is your product and this is what I promise, and you are paying and you are getting that. Okay, now the question is, how far did the product stay up to what I promised? How far did the product stay up to what you expected? Here the understanding is that your expectation and my promise were more or less the same. They can be different. They can be different. For the purpose of selling, I might make an over promise. Okay. For the purpose of buying it for the first time, your expectations could be more. There could have been a hype created because of the advertisement. So, your expectation is slightly more. That is okay. There will be a slight difference. But end of the day, the question is, how far did the product live up to the manufacturer's promise, or how far did it live up to your expectations? Okay. So, that is one part of quality. So, to go with what Kuldeep was trying to say is, if you have a product, so I have a pen, right. So, if I am going to talk about the quality of the pen, the first question is, what is this pen supposed to do? Simple. The pen is supposed to write. So, the point is, when I open and write, this guy should write today, tomorrow, next week, 10 days from now, 1 month from now. So, the deal is, this is the promise that the manufacturer gives me. You buy my pen, it will write. That is the basic performance that is expected out of this pen. It will do this performance every time you try to do that. You cannot say, oh, it will write for the first 2 times. The third time maybe. Then I will not buy your pen. It should perform every time you would like to do, to the extent. After 5 years, will it write? Unlikely. Will it write after 3 months? Maybe. But there is a limitation to it. They will say that it is going to work for these many days. It is going to work for these many hours. It will work for this much time that you are going to write. How many pages you will write. Okay, someone might write 10 pages, someone might write 1 page per day. So, I cannot always give a time limit on it. How many words are, how many usages. For sure, for those many usages, it has to stay fit and it has to serve the purpose. So, the important part is perform every time you want to do that, okay, governed by the time factor. So, how many ever times I do it in that time, limited time, it should perform. So, that is what one way of looking at quality. Okay. But there was this one guy from Japan who actually took an entirely different perspective on quality. Okay. You know whom I am talking about? There is this guy who is actually an electrical engineer called Genichi Taguchi. Okay. So, Taguchi techniques, orthogonal array and all that is very famous. Okay. He is a Japanese electrical engineer who post World War II, okay, Japan was under tremendous pressure to manufacture quality products. Okay. But then the material that they got was not really great, but in spite of that they wanted their products to be quality, okay, had to meet some quality. When I mean quality, the quality was always meant how far or how much you are deviating from the promise. So, if you are saying it is x kilometers per liter, how much are you deviating from that? That is how the definition of quality is. Okay. So, he comes up, Taguchi came up with this orthogonal array and SN ratio. He brought his learnings from electrical engineering to manufacturing industry. Okay. He used concepts, mathematical concepts from electrical engineering into manufacturing industry, and that was a phenomenal success. Even today people are using what Taguchi did. Okay. So, it has been, of course, there are some limitations and all that, but there is no doubt that it was a runaway success in the manufacturing industry even today. Okay. That is where the Six Sigma and all those ideas emerge from. Okay. So, the quality can usually be measured, that is what everyone said, right, like all the three answers was on some specification. What is the specification? The promise. The promise is what the specification is, but predominantly you told it on the desk, on the showroom, okay, but it can directly be applied to the performance also. When I say performance, the simplest example that you can imagine about is your kilometers per liter, that is my performance, right. Or if you are all youngsters that you want to buy, I do not know what you look at the modern bikes these days, like 0 to 100 kilometers, speed in like 60 seconds, you know. Does it do that every time that you want to do it? Okay, that is one thing. So, the point is it's the product's performance deviates from its target or what I promise. How much does it deviate is another question. Okay. The interesting perspective that Taguchi brought in is, he says if the product does not live up to the buyer's expectation or it does not live up to the manufacturer's promise, who all gets affected? So, immediately there are two people who are involved in this transaction, one is the buyer, one is the seller, right. So, these two people are affected, but that is all predominantly people have looked at, okay. But he brought another one. He said the society is also at loss. There are different perspectives to this, okay. So, we will take a simple example and we will see where the society comes into picture, okay. So, there is take a car breakdown example, okay. So, let us imagine, I mean this is unlikely to happen, but let us say that the breakdown is unlikely to happen, okay. So, let us say that I bought a new car, let us not worry about the brand, I bought a new car, and any new car is supposed to have a very nice engine, at least in the initial months, right. Like after about 6 months, which is still the engine is very young, it is not expected to fail, and I am having a classroom of 60 people waiting to attend my class, and I am driving from my home and right around the junction outside the institute, you know, if at all you are there in the morning, let us say around 9 o'clock, 9:30, you know what the traffic is, okay. So, right just before I enter the flyover, okay, I have not entered the flyover, I am not gone on the left, okay, I am right there, my car breaks down, okay. So, I am heavily disappointed because I did not expect this failure, it is only 6 months old, and the manufacturer is also not happy because he did not expect the failure, they did not expect the failure, and it does not end there, there is a problem for them. okay, because it's covered under warranty. So, warranty means it's cost for them. They need to tow the car, they need to fix the part, they need to bring it, they need to give a replacement car to me until this car comes into picture. Okay. So, this is only the two people. Okay. But if my car gets stuck at 9:30 right in the middle of the road, what happens? So, do I know the guy who's behind me, who's 10 rows behind me when I am in the car, when my car is broke down? They have nothing to do with me. Okay. So, that is what the society is. And there might be some important doctor who's parked 10 cars behind me, who has an important surgery at 10:30 that morning. Okay. So, you are going to affect innumerable people. You cannot imagine to what extent the effect is. Okay. I might still end up clearing the car and the road in about 15-20 minutes by getting out of the car and pushing it and all that. Okay. But even that 15-20 minutes, there is going to be a lot of traffic jam. I do not know if you understand the traffic jam that I am talking about. 15 minutes is fair enough to delay people by about an hour easily. Okay. So, the point is, what Taguchi says is there are three factors that play a role when you try to define quality. So, it is the user, it is the manufacturer, and it is the society. Okay. Then he says it should be measured as a total loss to the society. This is a very interesting perspective. Okay. Later, we will talk about a loss function that Taguchi advocated to use to measure quality, and the loss function talks about, as the word defines, it only talks about the loss. It only measures the disappointment of someone. It does not measure how happy you are. You can be like 3-fold, 5-fold, 10-fold happy, but the loss function does not capture that. It will only capture how unhappy you are, because that is what matters in terms of quality, not the positives. Okay. So, what Taguchi says is the quality needs to be measured as a total loss to the society due to the functional variation. See, this is the important part. The variation, end of the day, you can say it is from the material property, it is from the operational conditions, this, that. End of the day, what matters is how well did that product function. It could be for any reason. The breakdown could have been for anything. Okay. It could have been a purely genuine reason. That does not matter. End of the day, the engine did not perform its performance. It did not live up to the performance that was promised to me. If the same breakdown happened after 3 years, I understand. I did not maintain the vehicle, so it did not. But then there was a promise that was given by the dealer that at least for 3 years your engine will be fine. But that was not the case here. Okay. So, the loss to the society, often it cannot be quantified. Okay. But there are ways and there are economic models that try to quantify this. Okay. And harmful side effects. The one thing that we spoke about is not necessarily a harmful side effect, but harmful side effect predominantly comes from a sustainability perspective. What do you do with the products that do not work fine? For instance, now people have started including in sustainability the tolerance and how well you manufacture to the specifications, because if you manufacture a washer, and let us say that I will take your washers only if it is greater than 4.8 mm or lesser than 5.2 mm. Okay. You manufactured about 1000 washers that were not within this specification. What do you do with those washers? You will throw them. There is an environmental impact of that. Okay. So, now that has to be taken into account. You cannot just say, oh, that is, I am a manufacturer, so what, it is a loss to me. No, it is not just a loss to you, it is also an impact to the environment. So, you have to mend your design conditions or your manufacturing conditions such that you will not generate that waste. So, now sustainability is being brought into the design cycle, just like how we spoke about quality being or robustness being brought into the design cycle. Sustainability is also being brought into the design cycle. Okay. So, this is one way of looking at quality, right.